So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the theme of quadratics with a focus of looking at turning points on the higher syllabus, and I'll also include going through some exam questions which, if you'd like some access to, all you need to do is click on the link in the description below and you can have an attempt at these questions either before watching this video or while watching. Now, on a curve, the turning point is where the gradient changes from positive to negative or negative to positive, and at this point the gradient is 0. Often after plotting a quadratic curve, what we call a parabola, you may be asked to state the roots where the curve crosses the x-axis or where the equation equals 0, and or state the turning point or the stationary point as a coordinate or their x or y ordinate. Now, at higher GCSE level maths, you may not be given a graph, but you can use completing the square as a way of finding these two calculations of any quadratic equation without plotting or sketching. Now, if you are given a sketch or asked to sketch a quadratic equation, you will end up with what we have called is a parabola. So if I just label these axes as y and x, and if we have a positive parabola which looks like a U shape, then these 2 points here are going to be our roots, or the values of x where the equation equals 0, and this point here is going to be our turning point. Now, it's just coincidence that this looks like it's on the y-axis. You may find that your turning point may just be floating, but that there would be your turning point. So for example, if I had a graph that looked, let's say, like this, then this here would be my turning point. Now, in terms of related to the gradient, well, here, if we look at this, the left-hand side of the turning point on this particular parabola, here we have a negative gradient. And if we look at the right side of the turning point, so let's just use a different color, let's go for darker blue, then this region here is where we have a positive gradient. Now, if, for example, we ended up with, let me just get rid of all of this. So let's say we had a negative parabola, then it would be the complete opposite. So for example, if I just do a negative parabola, so let's look at this, again, not greatly drawn. So this here would be our turning point, but these two values here would continue to be our roots. And obviously on this side of the turning point here, we've got a positive gradient, and on this side here, we have a negative. Let's just make sure that looks like a negative. We've got a negative gradient. Now, just bear in mind that with a parabola, you're always going to have a turning point, but you may not always have roots, and you might find that at high level, so for example, if I just deal with positive parabolas, so you could end up with a quadratic equation that has 2 roots. You could have one that has 1 root, or you could have an equation that has 0 roots. So the roots are basically where the parabola crosses the x-axis. Now, sometimes you may get asked to find the root. Sometimes you might get asked to solve the quadratic, in which if you've got a graph, it's basically going to be where the curve crosses the x-axis. So let's have a look at using completing the square to find the roots and the turning points when you've got no graph. Now, when you've got a graph, it's dead easy to find the points and those turning point and the roots. You just got, and it'll only be worth 1 mark because all you're doing is just picking information from a graph. But if you haven't been given a graph, then the marks for finding the turning point or the root is going to be considerably more. Now, for this, the first thing you want to do is factorize the quadratic equation into the form of completing the square, which looks something like this. Now, in its current state, which I've highlighted, your A is positive and your B is positive as well, but you may end up with a question where they are opposite signs. So you could end up with something like x minus 6 squared plus 16, where a equals 6 and b equals 16. I could end up with x plus 5 squared minus 1, where a equals positive 5 and a equals minus 6 there, and here b equals minus 1. So again, just be mindful of that just because the format says, well, in the sort of template it says plus, a and b could be negative values. Now your turning point is at this coordinate here. Now the minus a is basically the value of x that makes the bracket equal to 0. So again, when you've got a negative a already in the format, you want to change the sign of a basically. So just to go over that, let me just give you some examples of, and let's find the a and b values of this, or the turning point. So we have an equation and we've got the turning point. Let me just give you some quick examples. So here, let's go for x plus 2 squared minus 4. So looking at the bracket, to make this bracket equal to 0, I need to make x equal to minus 2. So that's going to be the x ordinate. And then the y ordinate is whatever number is at the outside the bracket, which is minus 4. So my turning point is at minus 2, 4. If I had the equation of x minus 3 squared plus 9, so the value of x that makes this bracket equal to 0 is going to be minus 3. And the number at the end is positive 9, so the turning point is at minus 3, 9. If I had, let's say, x minus 1 squared, just that, then here the value of x that makes this bracket equal to 0 is going to be 1, and I've got no number at the end, so it's just 0, so the turning point is at 1, 0. So just be mindful of that. Now to find the roots, all you need to do is basically make the equation equal to 0 and solve for x. So for example, e.g. if I had to let's say find the roots of y equals x plus 4 squared minus, let's say, 20. So for this, what I need to do is make it equal to 0. So x plus 4 squared minus 20 equals 0, and then solve it for x. So I've got x plus 4 squared, take the 20 over to the other side, then I square root, remembering it's going to be plus or minus root 20, and then take the 4 over, so x equals plus or minus root 20. Now just bear in mind that the roof of the square root stops at 20, and I've got minus 4, so that is the two values. So my two roots are going to be minus root 20 minus 4, or positive root 20 minus 4. And that's where the parabola will cross the x-axis. Now for the line of symmetry, that's always going to be x equals whatever number a is. So whatever number you've got that's being added or subtracted to x, that equaling x will be your line of symmetry. So for example here, if I had, again, just quickly draw a parabola, and let's say this point here is at 2 minus 8, then the line of symmetry is going to be, well, this is my x ordinate, so it's going to be what x equals 2. There's going to be line of symmetry. Now for the y-intercepts, again, you could expand the brackets and whatever the constant is, that's going to be the y-intercept, or you can basically just use the format of a squared plus b. I wouldn't bother personally remembering that. I would probably just expand the brackets and simplify and collect all the constants together. But if you want to be quick, yes, the y-intercept of a parabola that's already been formatted in the completing the square format will be a squared plus b. So now let's have a look at some exam questions relating to the turning point and roots and using completing square in general. Now, if you wanted a copy of these questions, then all you need to do is just click on the link in the description below, and you can either have a go at these questions before watching this video or have a go while watching this video. So looking at question 1, it says that the equation of the curve is y equals x minus 1 squared minus 6. Circle the coordinates of the turning point. So again, looking at this, we want to try, the x-ordinate will be the value of x that makes the bracket equal to 0. So that's going to be positive 1. And the number at the end is minus 6. So we're looking for the coordinate of 1 minus 6, which is our last option. Looking at question 2, it says that the turning point of a graph y equals x plus a squared plus b has an x coordinate of minus 2. 3, 1 is another point on the graph. Work out the y ordinate of the turning point. So for this, basically it's asking us to work out what b is. So from this, as the x ordinate equals minus 2, that means that a is going to equal positive 2. So from this, what I've got so far is x plus 2 plus b, and obviously that bracket there is squared. Now, using the information that's been given to me, this is telling me that when x equals 3, y equals 1. So if all of this is equal to y, if I substitute these numbers into this, then what I end up with is 1 equals, and it's going to be 3 plus 2 squared plus b. So then simplifying all of this, I get 1 equals, and it's going to be 5 squared plus b. So I've got 1 equals 25 plus b. So b therefore must equal minus 24. So the y ordinate of the turning point is going to be minus 24. So again, if I wanted to, I could write the turning point coordinate, which is going to be minus 2 minus 24, but the question's just asking me for the y ordinate, so it's just that number there. If I gave the coordinate, I probably would lose a mark. Moving on to question 3, it says that the curve has the equation of y equals x squared minus 6x plus 17. The turning point of the curve is at a8. By completing the square, otherwise work out the value of a. So let's just go on to use completing the square. So there are several methods which we could do to do this. I'm just going to go straight into completing the square. So here I've got x and squared plus 17. So then if I divide the coefficient of x by 2, so that becomes minus 3, and then take away whatever number is inside the bracket squared. So then that then becomes x minus 3 squared plus 17 minus 9. So then x minus 3 squared plus 8. So then here, what I've got, I can then work out my turning point coordinate. So the turning point is going to be at the value of x, which makes the bracket equal to 0, which is positive 3, 8. And the question is asking me to find the value of a. So a equals 3. It then says the turning point of the curve y equals x squared plus 4x plus b has a y ordinate of 8. Work out the value of b. So for this, let's have a look at what that's going to be. So from this, if I look at the turning point, so looking at this, the turning point, if I use completing the square, is going to look something like this. Now the y ordinate of the turning point, all of this has got to equal 8. So therefore b minus 4 equals 8. So therefore b equals 12. Moving on to question 4, it says here is a sketch of a quadratic curve. The turning point is 3 minus 2. Circle the correct statement about the gradient of the curve for when x is less than 3. Now x is less than 3 is, well, at this point here, that's where x equals 3. So I'm looking at what's happening with the graph when it's on the left hand side of that marker. So I'm looking at this. So on that yellow line, what is the gradient doing? Well, the gradient is negative. So the correct one I should have is going to be this. Now it's only when x equals 3 is the gradient going to be equal 0. So when values are, we know that x is less than 3, then the gradient is definitely going to be negative. So looking at question 5, it says here is a sketch of y equals x squared plus bx plus c. The curve intersects the x-axis at 5, 0 and at point P, and the y-axis at 0, minus 10. And the question is asking us to work out the x-ordinate of the turning point of the graph, and this question's worth 4 marks. So let's have a look at the 2 points that we have been given. So this point here, we've got is 0 minus 10. And so when x equals 0, y equals minus 10. And at this point here, we've got when x equals 5, y equals 0. So if I just call this point #1, and so substituting these values into the equation that we've got, what I end up with is 0 equals 5 squared plus b times x. Well, if x is 5, that's going to be 5b plus c. So simplifying all of this, I get 25 plus 5 plus c. So 5b plus c equals minus 25. And I'm just going to put a little box around that. Then doing exactly the same, but for these values here, I end up with minus 10 equals 0 squared plus 0 times b plus c, which basically gives me that c equals minus 10. So then if I then substitute c into this as equaling minus 10, I end up with 5b minus 10 equals minus 25. So 5b equals minus 15. So b equals minus 3. So here from this, what I've then worked out is that the equation of the curve is going to be y equals x squared minus 3x minus 10. Then from this, if I can then use completing the square to then work out the y ordinate, well, from this, all I'm focused with is what goes inside. Because I'm looking at the x ordinate, the only thing I'm focused on is what number is going in the brackets. So here it's going to be minus 3 over 2, and that's going to be minus 3 over 2 squared. Now, as I've said, the only thing I'm interested in is the x ordinate. So all I'm interested in is this bracket. To make that bracket equal to 0, what must x equal? Well, x equals positive 1.5 or 3 over 2, whichever you prefer to write your answer. Moving on to question 6, it says the equation of the curve is y equals x plus 3 squared plus 5. Circle the coordinates of the turning point. So again, looking at my bracket, to make that bracket equal to 0, x must equal minus 3. And the number at the end is positive 5. So I'm looking for the coordinate of minus 3, 5, which again is my last option. Then moving on to question 7, it says write x squared minus 10x plus 29 in the form of x minus a squared plus b. Now don't be too concerned about the minus, because obviously this is minus here. So again, it's just giving you a helping hand. Basically what this question is asking us to do is just to write it in completing the square format. So again, I've got x squared plus 29. So I just need to write down the numbers. So if I divide the coefficient of x by 2, that becomes minus 5. And take away the number, the digit inside the bracket squared. So that then becomes x minus 5 squared plus 29 minus 25, which gives me an answer of x minus 5 squared plus 4. Next question then says a sketch of y equals x squared plus cx plus d is shown, and it's given us our points here. It says work out the values of c and d. So from our turning point, if I then use completing the square, that here a is going to equal minus 3 and b equals 5. So then substituting it into this, I end up with y equals, and then it's x minus 3 squared plus 5. Now I need to expand the bracket so I get it into unfactorized form. So y equals x plus 3 x minus 3 x minus 3 plus 5. So expanding this out, I get x squared minus 6x plus 9, then plus the 5. So I get x squared minus 6x plus 14. So then from this, c equals, let's scroll down a little bit. So from this, c equals minus 6 and d equals 14, and there is my final answer for that one. Then moving on to question 8, it says write x squared plus 6x plus 10 in the form of completing squares. So again, setting up my format, Divide this by 2, so I get plus 3, and then take away the number inside the bracket squared. So x plus 3 squared plus 10 minus 9 leaves me with x plus 3 squared plus 1. It then says, hence write down the corner at the turning point. Well, to make the bracket equal to 0, that needs to be x needs to equal minus 3, and the number at the end is 1. And so the corner at the turning point there is going to be minus 3, 1.